Let us see this fx equal to mod x in the interval minus 1 to 1. Now this is what I had explained actually just some time back. The function fx equal to mod x. Why we do not apply? Why we cannot apply Rolle's theorem to this? It is very important to understand what is happening. You can see that this is f minus 1 and f1 both are 1. Now they are not equal to 0, that does not matter. They have to be equal. They don't have to be equal to 0. They have to be equal, and therefore they are equal. That is good enough. Whether they are 0 or not does not matter. So now whether it is continuous or differentiable. Now again, if you remember the graph, you can see that the function is continuous, but it is not differentiable at x equal to 0, and therefore B is your answer. That is why you cannot apply Rolle's theorem to that. I've shown you the derivation I've shown you that the limit, the left hand limit and the right hand limit, they are different. The derivative on the left hand side is minus 1 and it is plus 1 on the left hand side. No, it is plus 1 on the right hand side and minus 1 on the left hand side, and that's why right hand derivative and left hand derivative are not equal, then it is not differentiable. But you can very clearly see it. A very easy check is to see if there is a sharp point. If you see there is a sharp point in the curve anywhere, it means the function is not differentiable. Most of the times, visually you would be able to check whether the point is sharp or a sharp point or not. Sometimes you will have to actually differentiate and see, but most of the times, just by looking at the graph, you would be able to see whether the function is differentiable or not. Just like continuity of a function also, if you have a graph, visually, in most of the cases, you will be able to see whether the function is continuous or not. If you see a break, it is not continuous. If you don't see any break, then it is continuous.